E of 3. The previous sessions, I am explaining things related to the non-uniform flow. What is non-uniform flow? What is gradually varied flow as well as rapidly varied flow, and what about the situations at which the gradually varied flow occurs as well as rapidly varied flow occurs and all these things. And then I am explaining things related to the hydraulic jump. What is hydraulic jump? What about the situation at which hydraulic jump occurs and all these things? Usually, the hydraulic jump occurs when the flow changes from supercritical to subcritical flow. Means supercritical means the value of F is greater than 1. Subcritical means the value of F less than 1. F stands for Proud's number. Proud's number. On the basis of the Proud's number, it is possible to find out the what about the hydraulic jump is occurs in the particular situation or not. And also another way of find out the whether the hydrogen occurs or not means the y1 value or d1 value before hydraulic jump is less than critical depth of flow. Critical depth of flow is the depth of flow where critical energy occurs, or EC. At EC, depth of flow is YC. And also the Y2 or D2 depth of flow after hydraulic jump is greater than YC. In such a situation, also the hydraulic jump occurs. And also, I am explaining the derivations which use the relationship between hydraulic jump. Y1 means depth of flow before jump, depth of flow after jump, as well as the small q. Small q stands for discharge per minute width. And from that continuation of that particular one, we derive a relationship between y1, y2 as well as Proud's number. Proud's number means whether the value of f1 stands for before jump, f2 stands for after jump. So we derive a derivation and show that the relationship between y1, y2 as well as f1 are. And continuing the particular one, next we derive an equation which gives the relationship between the what about the loss of energy with respect to the depth of flow before jump after jump. Definitely once the hydraulic jump occurs, there is some amount of energy loss occurs. The particular loss of energy is called as energy dissipation. So it is possible to find the loss of HL or loss of energy is by deriving the relationship between HL equals E1 minus E2, where E1 is the specific energy at section 1, E2 stands for specific energy section 2, and substituting the equation E1 equals Y1 plus E1 square by 2G, E2 equals Y2 plus E2 square by 2G, and things and simplify, we get the relationship between HL, B1, B2. And also we have derived the relationship between Y1, Y2 and 1. And we derive or get the equation for what about the height of the jump. Height of the jump is y2 minus y1 as well as length of the jumps. Jump usually it is 5 to 7 times, usually taken as 6 times the height of jump. So once you are familiar with the derivations, the equations and all these things, next it is better to pass on to the solving some of the problem related to the hydraulic jump. The examination usually hydraulic jump is one full question, and remaining profile of the water, profile of the slope, and a gradually varying flow is another question. Rapidly varying flow, one question, and gradually varying flow, another question. So in rapidly varying flow, when hydraulic jump is there, so they may ask the derivation as well as the problem creation. So it is better to go through the problems, some of the problems related to the hydraulic. The first problem is depth of water at a certain section of rectangular channel of 2 meter wide is 0.3 meter. Means is given the value of V1 as well as Y1 or D1. The discharge through the channel is 1.5 meter per second. This is given the value of 2. Determine whether a hydrogen will occur, and if so, find its height and loss of energy per kg of water. So usually they are asking, first thing is whether hydrogen will occur or not. So how to decide whether hydrogen will occur or not on the basis of the Proud's number. So first, if it is possible on the basis of data given, to find out the value of F1 and find out the value of F2. Then the F1 is greater than 1, then supercritical flow. F2 is less than 1, then it is subcritical flow. Once the flow changes from supercritical to subcritical flow, then only hydrogen. So on the basis of the Proud's number also it is possible to find out or check out whether jump occurs or not. Otherwise, another way is on the basis of the values of Y1 and Y2. If hydraulic jump occurs, then the value of Y1 is less than YC. YC stands for critical depth of flow. Critical depth of flow is where the specific energy is V or EC. And Y2 is greater than YC. If these two conditions are satisfied, then we treated as the hydraulic jump is occurs in that particular situation. So first, you go through the data given. So as per the data given, depth of flow is given before jump D1 or Y1, it is 0.3. Width of the channel B is 2 meter. Discharge is given 1.5 meter per second. So once is given the value of discharge, usually this DQ is stands for Q, capital Q, 1.5 meter per second. But you find out the discharge per unit width. Discharge per unit width. So discharge per unit width is equals to discharge in the channel by width of the channel. Discharge by width of the channel. Okay, so if you find out the small q equals discharge is 1.5 and the channel width is 2 meter. So 1.5 by 2, we get 0.7 meter per second is the discharge per unit. Discharge per unit. Here, if it is possible, we go for find out the value of F1. But if we want to find out the F1, we want F1 equals V by root G Y1. So we want V1. So we find out the value of V1 from this equation. If possible, V1 equals Q by A. Otherwise, it is possible to find out the critical depth. We know that in the specific energy chapter, we derive an equation critical depth YC or HC equals Q square by G to the power of 1 by 3. Okay, so once we know, otherwise YC cube equals Q square by GB. So on the basis of that, it is possible to find out the critical depth of flow of a given data directly. So anyway, we know the value of Q, so we know G, so directly substitute and we get 0.75 square by 9.81 to the power of 1 by 3. We get 0.3859 meter. Means HC is greater than Y1 or D1. D1 is 0.3 and DCHC is 0.3859. Means the D1 is less than YCHC or critical depth. Therefore, the hydrogen may occurs. Therefore, hydrogen may occurs. The depth of upstream side is 0.3. This depth is less than the critical depth, hence hydrogen occurs. Usually, first you find out whether hydrogen occurs or not, and then you go for next things. So once you decide hydrogen occurs on the basis of y1, yc, y2 or f1 and f2. So next we pass on to find the other parameters. So you know d1, you know small q. From that, it is possible to find out the value of depth of flow after hydraulic jump. Okay, so equation to find out the relationship between d1, d2 as well as small q and all these things. Written as d2 equals d1 by 2 plus d1 square by 4 plus 2q square by g d1. In this case, we know d1, we know q, we know g, and substitute 0.3 by 2 plus 0.3 square by 4 plus 2 into 2 is 0.75 per second per unit width square divided by 9.81 into 3 and simplify, we get 0.4862, which gives the value of d2. d2 means depth of flow of the picture. From this, you observe d1 is 0.3, DC or YC is 0.3689 and D2 is 0.486. Means Y1 is less than critical depth and D2 is more than critical depth. Therefore, hydraulic jump is occurs. Satisfy the conditions of hydraulic jump. So, and also is hard to find out the rate of the jump. Rate of jump is the difference between D1 and D2 or D2 minus D1. So 0.4862 minus 0.3, we get 0.1862, which is the height of the jump. And also he is asked to find out what about the loss of energy per unit width is asking. So anyhow, we know that we already derived that loss of energy per kg of water jump is HL equals D2 minus D1 whole cube divided by 4 D1 D2. Here we know D1, D2 and all these things, and substitute and simplify, we get 0.01106 meter kg meter. Otherwise, in terms of liters of water. So like that, find out the value of height of jump and loss of energy and all these things. Next, we pass on to the another problem. A sluice gate discharges water into a horizontal rectangular channel. Sluice gates are the gates which are placed above the crest of the weir or spillway. Okay, so just to improve the storage capacity of the reservoir dam. If there is excess of water enter into the dam, automatically they raise the sluice gate, then water is allowed to move in between crest of the weir or spillway and bottom of the sluice gate with a high velocity. Then also hydrogen is occurs usually. With a velocity of 10 meter per second and depth of flow is 1 meter. Determine depth of flow after jump and corresponding loss of total height. So once again is given the data velocity of flow before jump v1 10 meter per second, depth of flow before hydraulic jump is 1 meter. So first you find out the discharge per unit width. Discharge per unit width. Unit width means Q equals AV. So where A equals D into Y. Okay, where unit width it is D11 or Y1. D into Y1 or B into D1. Where B is 1, so we can write it small q equals V1 into D1 equals 10 meters square per second. And 10 meters per second. Okay, once you know small q, once again the formula what we are using in the last same. D2 equals minus D1 by 2 plus D1 square by 4 plus 2q square by D1. You substitute, you know the value of D1 1 and you know the value of G and also you know the value of Q. So we get the value of D2 is 4.043. So total height is given HL equals D2 minus D1 whole cube by 4 D1 D2. So we know D2, we know D1 and substitute and get loss of head equals 1.72 meter. this gate discharges water into horizontal channel with a velocity of 6 meters per second and depth of flow is 0.4. Means is given the value of V1. V1 is 6 meters per second. Depth of flow V1 is 0.4. The width of the channel is 8 meters. Is given the value of V. Determine whether hydrogen occurs. First, you find out whether hydrogen occurs on the basis of the conditions, and if so, if occurs, find its height and loss of energy per kg of water. Also determine the power lost in the hydrogen. He is asked to find out the power loss. Such type of problems are very important at the point of examination. Okay, so here what should decide whether hydrogen occurs or not. How to decide, on what basis you are deciding? On the basis of once the flow changes from supercritical to subcritical flow, then hydrogen occurs. Supercritical means what? F1. F1 is greater than 1. What about subcritical? F2. F2 is less than 1. If the value of F1 is greater than 1 and F2 is less than 1, then hydrogen occurs. Otherwise, the value of Y1 is less than Yc and Yc is less than Y2, then also or D2, then also hydrogen is occurs. So first you find out the value of small q, discharge per unit width. Is given the discharge as well as width of the channel is given. Okay, so discharge width of the channel is given and discharge is given. So q equals v1 d1 into v by b. Q equals v into a. So here v cancel, remaining is v1 to d1. v1 is 6 and d1 is 0.4. So discharge per unit width is 2.4 meter per second. So from that, first we find out the Proust number. Proust number. In the first problem, we find out the value of Yc. On the basis of Yc, we decide hydrogen is occurs in all these things. But this problem, we find out the value of F1. F1 stands for Proust number before jump. We know velocity, we know depth of flow before jump, and substitute it v1 by root gd1, 6 by root 9.81 into 4.4, so get 3.089. It is greater than 1. If it is greater than 1, then it is supercritical flow. Means before jump, there is a supercritical flow. So Proust number is more than 1. The flow is shooting on the upstream side. Shooting flow is suitable for suitable flow, and it will convert itself into streaming flow by raising its height, hence hydraulic jump will take place. First, you conclude whether hydrogen occurs or not. You write on the sentence. Yes, hydrogen occurs. Why? The value of F1 is greater than 1. Simple. Okay. Once you decide hydrogen is occurs, then find out the depth of jump on the other side or after jump, D2 or Y2. So once again, we know the value or relationship between D1, D2 as well as Proust number. It's already derived. So D2 equals D1 by D2 into square root of 1 plus 8 F1 square minus 1. So we know D1, we know F1, substitute and get the value of D2. So we get the value of D2 is 1.525 meter. Once you know D2, you know D1 and all these things. So from that you find out the value of height of the jump. Height of the jump is D2 minus D1. D2 is 1.525 and D1 is 0.4. So height of jump is 1.125 meter. Okay. Once you find out the rate of jump, is also to find out the energy per kg of water. Energy per kg of water is HL equals D2 minus D1 over 2 by 4 D1 D2. So we know D2 0.525, we know D1 4 cube by 4 into 0.4 1.525. We get 0.58 meter of water. Kg cancel, it is liter of water. But he is asked to find out the power loss in terms of kilowatts. Power loss in terms of kilowatts. So this can be found out by using rho g into q into HL by 1000. But here q stands for capital Q stands for discharge for whole channel cross-section area. Be careful. So V equals Q equals V into A, where V1 is 6, V1 is 0.4, width of the channel is 8 meter. Don't go for small Q. Small Q is for unit discharge. So here we get Q equals 19.2 meter per second. 19.2 meter per second. So we substitute rho equals 1000 K G 9.81 19.2 into loss of head is 0.5835 meters of water divided by 1000, we get 109.9 kilowatts of power is lost in this condition. In this condition. So next we pass on the previous problem is very important. Be careful. Usually in the examination they are asking the automatic power loss for the given data and all these things. Okay. Next we pass on to another problem. The hydraulic jump forms at the downstream side of spillway carrying 17.93 meters per second. Discharge Q is given 17.93. If the depth before jump is 0.8, determine depth after jump and energy loss. Once again, usually he is changing data and all these things. Q is given. This one is 17.90, not 17,083. Sorry, this one is 17.93 meters per second. Depth before jump is V1 equals 0.8. Taking width is B is 1 meter. We get unit per unit width. It is 17.93 by 1. Okay, so here we assume the width is 1 meter. By using the relationship between V1 and V2, as usual, we get V2 equals 8.66 meter. By using the loss of energy equation, so we get HL equals 13.52 meter. Okay, relationship between V1 and V2 is what you are studying this one, and loss of it is D2 minus D1 whole cube by 4 D1 D2, and substitute and we get the value of HL is 17.5. Okay, thank you.